I'm going to talk to you today about the change that's happening in agriculture. This is happening very rapidly in the West. There is a lot of development in terms of IoT and in terms of big data and the complete digital economy and the connectivity of farms. Okay, firstly, I'm going to talk to you a little bit about where I'm from. I'm from the National Centre for Precision Farming, and I'm going to give you a brief overview of what the National Centre for Precision Farming is and how we work and how we interact with other agencies in the UK. I'm going to talk a little bit about some of our projects, some of the things that we've been working on, and some of the technologies that we're trying to develop. Then I'm going to drop back into farming and look at the issues that are facing world farming so that I can give you a little bit of a background about why this in technology and why these developments are so important. Then I'm going to go on and look at the farming revolutions. I'm going to go right back in time to the dawn of farming and look through how farming has developed. Having looked through how farming's developed, I'm going to look at where we are in terms of today's technology for connected farming. Then I'm going to have a look, for those of you from agricultural backgrounds, it'll be nothing new. It'll be just a quick look at agricultural GIS. Then I'm going to use the terminology for all of these IoT, big data, digital revolution that's occurring in farming has been given the title Farming 4.0, and I'm going to look at what a Farming 4.0 system actually looks like. Finally, I'm going to look at some of the ideas for the connected farming of tomorrow. We're going to go through and see how we've seen the state of the art. Well, where is this going, and what ultimately is it going to mean for farmers? Okay, so my background is I'm an agricultural engineer. I started in computer science back in the 1970s. I then moved into GIS. I then went into agricultural engineering, and I've been working at Harper University since the early 1990s. I was involved very early on in precision farming when the term was just being coined, and have been involved very heavily with it ever since. I work for a company an organisation called the National Centre for Precision Farming, which is based at Harper University. It's part of the university, and it's based within a building known as the Agri-Epicentre. The Agri-Epicentre is one of 4 research centres set up by the British government 4 or 5 years ago. What they did was they looked at research in agriculture, and they decided that they had needed to rethink the way agricultural research and development was carried out. So they set up 4 new centres. The first centre was set up was Agrimetrics, which is to do with computing and big data analytics. They then set up one for crop science and one for animals. The 4th centre that has been set up is the Agri-Epicentre, which is to do with precision agriculture, precision machinery, and it effectively brings together all of the other bits and works close to market to produce new products and to test and trial products in the marketplace. The Agri-Epicentre is based at 3 sites in the United Kingdom: Harper University, where I work, the Scottish Rural University College up at Edinburgh, and down at Cranfield University in Bedfordshire. As well as having the 3 centres, we also have 32 satellite farms. Well, it's actually 32 at the moment, but the number is actually growing. These are farms that are digitally connected farms where we put machinery, we can put sensors, we trial different things out on the farms. There are a range of farms, everything from livestock, cereals, aquaculture, so they cover all the different types of farm that we have in the United Kingdom. So we work very closely with the Epicentre. We're actually based in the Epicentre and work very closely with them to develop a whole range of research and development projects and trial equipment with them. Okay, so that's our headquarters in Harper Adams University. The role of the National Centre is to be a commercial research and development organisation within Harper Adams University. We specialise in precision farming, robotics, data analytics, and a range of other engineering topics. We have a dedicated team of scientists and engineers who work solely for us, developing new products and testing and trialling other commercial products for manufacturers. Okay, so some of the areas that we work in, we work very closely with partners in a number of different countries, in Europe, in Africa, in India, China, and Australasia. So we have partners in a number of those countries, and we're conducting projects in a number of those countries with both commercial and academic partners. And we're looking to develop things like robot vehicles. We've worked on robot harvesters, automated weed control, and I'll talk a little bit about some of these projects. We're looking at the use of drones and crop scouting. We have done a lot of work in precision agriculture and have been moving recently into the idea of the connected farm and farming 4.0 and big data. This is one of our projects. This is a robot tractor. We have produced quite a number of robot tractors. I won't show you all of them. What we tend to do is we can build dedicated robot tractors, but what we tend to do is take a commercial machine and then robotize it. It takes us somewhere in the region of about 3 months to completely turn any tractor or any machine into a robotic vehicle. It's quite simple, quite straightforward. We build the control systems on top, and then we can use it with a whole range of different sensors and positioning equipment so that we can navigate it around a whole range of different environments or different agricultural environments. Okay, so this machine has, this is a simple GPS-based machine, so it's got automatic steering and has a range of different sensors mounted on it that are there to primarily for safety purposes so that we don't bump into people or we don't hit objects as we navigate around. Another project that we have recently completed and are looking to move into the second phase of is a project to harvest strawberries automatically. We developed, in the UK there is a huge problem at the moment in that we have, because of Brexit, we are likely to lose a lot of the Eastern European labour that we use to pick fruit and vegetables. This has created a need to very rapidly develop robotic machinery to replace these people. We have, running in the UK, quite a number of projects at a number of different institutions that are all looking to develop robots to harvest and pick fruit and vegetables. We looked at strawberries. We developed a strawberry picking robot that could work as fast as a human could. It could pick strawberries as quickly as a human. It has still a few challenges to overcome, primarily challenges that are to do with looking at strawberries when they're occluded or hidden behind other berries and other fruit, and how you actually manipulate the tools in to pick those strawberries without leaving them behind. That's what we'll be looking at in the second phase of this project. Okay. We have also been, there's a lot of pressure in Europe to try and reduce the amount of pesticide and fertilizer that's actually being used on farms. And there's a lot of work going on to look at more precise application of both pesticides and fertilizers so that it's not leached out of the soil and doesn't get into the environment and it kills, if it's a weed killer, it kills the weed you want it to kill, doesn't get into the environment, doesn't get into the water courses, doesn't cause environmental damage to other plants and wildlife. What we have been doing is we're coming to the end of a 3-year project that has been looking at using different systems for looking at using different systems for eradicating weeds. This project is being done in conjunction with a large pesticide company called Syngenta, and they are very aware that there's a lot of new technologies being developed, and they sell pesticides. They are concerned that because they're selling pesticides, if they don't look at these new technologies and get actively involved in them, what will happen is somebody will come up with a smart mechanical way of getting rid of weeds, or a smart tool that will get rid of weeds, and suddenly pesticides will be redundant and they'll be left out in the cold. They see themselves now as a company that is responsible for destroying weeds, not a company that's responsible for selling pesticides or chemicals. So we've been working with them on a project. I can't show you, this is an early prototype of the machine. What it actually does is it identifies the weed. So it identifies the weed using a multispectral camera. It then, from identifying where the weed is, it targets a laser beam that fires at the weed and destroys the weed. We have actually, it's part of a two-pronged approach. There is also another system, which I can't tell you about because that's commercially sensitive, that destroys 98% of the weeds, and the laser is used purely to destroy the weeds that are very close to the actual plant. We are developing we're developing a drone center. We have been actively involved in drones now for the best part of 5 years, and we work with most of the drone operators in the UK and work very closely with the Royal Air Force, the Department for Transport, the Civil Aviation Authority, and the Chemical Regulation Directorate. In China, it's perfectly legal to take a drone and go out and fly and apply pesticides. In Europe, drones are treated as aircraft, and European regulations say that you cannot apply pesticides from the air. Therefore, we have been working with all of those different bodies to try and change those European regulations. So what we've been doing is looking at the system. So we test every drone to see how much pesticide it's applying. We look to see how much drift you're getting from the pesticide. And then we look at whether or not that is better than an actual spraying, ground-based spraying vehicle. We have done a whole range of trials and tests on a number of different manufacturers' drones, and we are just in the process of going into field trials so we can actually spray chemicals live on crops in the UK. We're also looking at developing we're looking with a number of manufacturers to develop drones for scouting purposes, and I'll talk a little bit more about those in a minute. One of the other challenges that we're looking to overcome is to develop drones that can fly beyond visual line of sight. I don't know how it is in Russia, but in the West there is a lot of concern about drones. There have been quite a number of incidents where people have gone out and you can buy a cheap DJI Phantom. You can fly the DJI Phantom anything up to several thousand feet. And there has been a spate of aircraft. People are interested in taking photographs of aircraft, flying them at the end of the big major runways of big airports. They fly the drone up, so as the aircraft takes off, they can get pictures of it taking off. The problem is that this really puts the aircraft, the commercial aircraft, at enormous risk. If the drone were to go into the engine of the aircraft, it would quite easily take the aircraft down. It would destroy the aircraft. There have been a number of very near misses in the UK, so there is enormous concern about people flying drones. What we have been trying to do is to look at, so at the moment the regulations state that you can only fly drones if you have somebody who's watching it and you can't fly it in certain areas. What we're looking at is, because for farming that makes drones uneconomic, we're looking at, can we build drones that can actually navigate themselves and can take the appropriate action. So if another aircraft comes into the airspace that they're working in, can take the appropriate action to get out of the way of that aircraft, and can, if it's operating at low heights, either spraying or doing crop scouting, can it maneuver to get out of the way of people if somebody suddenly walks into the area where it's working? So we've been looking at this problem with a number of manufacturers and are looking at how we can build drones that will actually meet these requirements. We think we have got most of this, the technology in place, but what we're looking to do is to actually trial some of these systems to see if they actually work properly. Another project that we've got is a project called Hands-Free Hectare. Okay, this is a project where we have used robotic tractors and robotic harvesters to produce a crop. So the entire crop, from planting it all the way through to harvesting, all the work was done with robotic vehicles. We used drones to take images of the crop as it was developing. We used a small scouting robot to go out into the field and take samples, both soil samples and crop samples. We used a robotic tractor to both drill and to spray, and then we used a robotic tractor and a robotic harvester to harvest the crop, ultimately. Okay. This project has just come to an end. It is going to be continued, and I can't tell you again because it's commercially sensitive. We have a very large manufacturer who is very interested in taking all of this technology and producing an entire robotic system. You'll be aware, or you may not be aware, manufacturers like John Deere and Claas and New Holland already have robotic vehicles. They haven't done all of this. The manufacturer that we're talking to doesn't at the moment have any robotic vehicles, but they're very keen to develop an entire fleet of new robots for replacing labour in some particular agricultural applications. Right. Jumping onto the issues facing world farming. World farming is really facing some very major challenges. At the moment, the world population is growing. I was in India only a few months ago, and an Indian very proudly came up to me and said, we're going to be the most populous nation in the world. We're going to outstrip China in terms of the number of people we're going to have. This is a really good thing for India. We're going to be the most populous country in the world. The populations in Africa, India, and in quite a number of other countries are growing quite significantly. The problem is that by 2050, we're going to need 70% more food than we're producing at the moment. So there's a real challenge over the next 30 years to find ways of producing more food. And the problem is that in most of these countries, the amount of land that is available for agriculture is finite. And as the population grows, people want houses, they want roads, they want new buildings. And because they want all of these new buildings, new facilities, the problem that you've got is then they start to build on the agricultural land. This means that there is less land then available for producing food. There is also another enormous problem. In a lot of these countries, the water that they're using to irrigate their crops is groundwater. So they basically drill a well, and then they take the water out of the ground, and then they use that to irrigate the crops. They've got this problem in China, India, and quite a number of Australia, and quite a number of other countries. As they take the water out of the ground, it increases in terms of salinity. They then put the water onto the soil, and it's increasing the salinity of the soil. At the same time, the water that they're taking out of the ground has been there, it's collected over thousands of years, it's not being replaced as quickly, as they're taking it out. A lot of areas, places like Jordan, will run out of groundwater within the next 30 years. So we have to find better ways of using water. Okay. We're also losing land to energy harvesting. In the UK, there has been a huge development in terms of putting in place things like solar panels, solar farms to collect energy. This year in the UK, in June, over 50% of the energy that was produced, that was used in the UK, the electricity, was generated from renewables, from either solar panels or from wind. Again, that is competing with farmland, so we have a competition there. Also, as the populations grow, they want more water for drinking, more water for washing. They want people's water consumption goes up. So there's a lot of pressure on what water there is in terms of competition from other uses. Climate change. President Bush may not feel that climate change is a reality, but I think everybody else recognises now that it is. In the UK, this is causing us huge problems because our climate is changing. We are looking very fundamentally at how we grow crops and which crops we grow, because the country is becoming wetter, we're having heavier rainfalls, and it means we can't grow the crops that we were traditionally growing. It's also becoming hotter, so we're having the problem of looking at how we can change our farming systems to accommodate this. Okay. In Europe, there's a lot of legislation and increasing restrictions on what farmers can actually do. Sustainability, I won't go through the entire list. There are a huge number of pressures. In Africa, they've got desertification, we've got salinity. So we're not only, farming is not only producing food, it's also destroying a lot of the farmland. And we are losing land, particularly in areas like sub-Saharan Africa and in Brazil, to desertification and to making the farmland, good farmland, unusable. So this is also creating a problem. Economically, any solution that we come up with has to be economic and has to fit within the economic, be affordable and achievable. Okay, so the line is basically, in the next 30 years, we're going to have to increase our food production by 70% whilst addressing all of these challenges, and at the same time, whilst having to deal with climate change. This is a huge challenge for agriculture, and if we don't get this right, you're going to see starvation increasingly in Africa. You're going to see migrations of people from Africa, particularly towards Europe and towards other countries. Right, jumping back 35,000 years, I'm going to run through very quickly the farming revolutions. We are now in an area that we're calling the fourth farming revolution, which is the digitally connected farm. The first farming revolution was when basically hunter-gatherers started to collect grain and cereal and then started to settle and build farms and started to cultivate the land. The second farming revolution came with the likes of the ancient Egyptians and the Chinese cultures when they started to go for commercial farming or managed farming. So you had labourers. Before, you just had somebody scratch a stick in the ground, throw some seed down, and then they collect the seed and they'd eat it themselves, or eat it, sell it, give it to their family. The Egyptians and the Chinese started to manage the labour. They started to put in things like irrigation systems. They started to cultivate. They started to go for selective breeding in terms of improving the kind of animals that they had. The third farming revolution occurred along with the Industrial Revolution and was really based on using larger scale farming. With each of these, here we have villages, here we have small towns and small cities. Here we have large scale cities. We have banking. Okay, so here we have the introduction of money. Here we have the introduction of banking. And we're looking at things like steel tools, tractors, combine harvesters, milking parlours, and modern agricultural machinery. The fourth farming revolution is what we call digitally connected farming. And that is a farming revolution that we're just in the process of going through. Right, the takeaway fact, the thing that is important about this is looking at the periods of time that these farming revolutions took to take place. The first instance of people actually starting to farm was 37,000 years ago. That period ran right up to about 3,500, 4,000 years ago. That's when we had the end of the Ice Age. This is when farming started to take off. And about this period, which is about 3,000, 3,500 years ago, you started to find the Egyptians and the the Chinese started to develop the second farming revolution and started to use labor. The third farming revolution started about 350 years ago and is just coming to a conclusion. The fourth farming revolution that we're just in is the digitally connected farming, and I'll talk a little bit more about that in a minute. Okay. The thing to note is 35,000 years, 3,500 years, 350 years, possibly 35 years. We are in a logarithmic progression in terms of technological development. That goes for not just farming, but for all technological development, because technological development and farming are very closely aligned. We are likely to see change within our lifetimes, quite fundamental and major change within our lifetimes. Okay, so connected farming today, I'm going to go very quickly through these. At the moment, this is a good example. John Deere have a system where they collect a huge amount of data from a vast number of sensors they have on their machines. That data is downloaded to a data center. The data is then processed, and it looks at how that machine's performing and how that machine's working. It then predicts, from looking at that data, if a part needs changing or if the machine needs repair work. It then orders the parts that need to be done automatically. Those are sent straight to the local dealership for that tractor. They then load it onto the service engineer's car. He drives straight out to the field. He drives to the field. The tractor driver's not even aware that there's a problem. He then phones up the tractor driver because he knows where the tractor is because he's got the GPS location of it. He then stops the tractor, jumps out of his van, fixes the tractor, and the tractor driver's not even aware that the machine needed repairing. That's one example of digitally connected farming today. Second example is combine harvesters. In Europe, Class monitor all of their combine harvesters. They look at how they're performing. They look at the combine harvester. They see how well it's performing. And having seen how well it's performing, what they do is they send all of that data back to the center in the UK, which is in Germany. So the data is collected from every single combine harvester they have working in Europe. They then look at all of the other combine harvesters and they see which one is actually performing best. And having looked at the combine harvester that's performing best, they then send back the settings for that combine harvester and adjust all of the other combine harvesters that are working in similar crops in a similar area so that they can optimize the performance of those combine harvesters to make them work better. Okay, so that's a second example of where we are in terms of IoT and digitally connected farming. Third example is with dairy. So we were working on a project called the DAISY project. This is another project that we're involved with, where we have a series of smart sensors that are mounted onto the legs of the cow. The sensors are mounted onto the legs of the cow. As the cow moves around, it's got an accelerometer in the sensor. The accelerometer in the sensor records how the animal's behaving. By tying that information is downloaded in batches, in large quantities. By monitoring how the animal's actually walking and maneuvering, what you can do is you can tie it with other information from a range of other sensors, and you can work out whether the animal's facts about the animal's fertility and the health of the animal. Okay, so you get advance notice of it if an animal's got a problem. This technology is important, particularly in the West, where you're starting to have herds of 400 or 500 animals, and the herd manager cannot keep an eye on every animal all the time. Okay, moving on. For those of you not familiar with geographical information systems, we are collecting information on farms in vast quantities. We are taking satellite images, we have drones going over and flying, we have soil maps, we have yield maps, we have a vast quantity of information that we're collecting on agricultural land and farming. That information is stored in a whole range of different databases. What GIS does is that it takes all of these different, from visual all the way through to things like yield maps. It takes all of this information and it overlays it so that you can drill down through all these different maps to find out for any point in a field exactly what's been going on and what's happening within that point in the field. That information is then used by agronomists. The agronomist looks at that information, and having analysed all that information, he then goes and gives the farmer some advice in terms of what to do. Okay, sorry, a couple of slides have disappeared. The modern approach is rather than using an agronomist to look at all of that information and all of that data and then sit down and analyse it himself, is we are using increasingly smart AI tools. So we're using a range of smart AI tools that are going to analyse that data or are in the process of analysing that data. The use of those tools is what's known as farming 4.0. So by using smart analytics, what we're doing is using the smart analytics to do the analysis of the data, and that is what's basically creating farming 4.0. Okay, so the connected farming of tomorrow. What does that mean that we can do? Right, one of the things that we can do is that the technology exists today, and this is one of the areas that we're interested in working in, and one of the interest areas that we're talking to a number of companies about. You can take the data that's been collected by satellite images, and on the satellite image, it can be analysed online without the farmer having a look at it. The data is analysed online, and in each field, there are areas of interest that are highlighted. Those areas are then, first thing in the morning, an increasing number of farmers in the UK and in Western Europe are now buying drones. You have a drone that's basically an autonomous drone that takes off, flies to that particular area in the field. It then goes down, it uses a hyperspectral camera and other sensors to look at that area. It then takes images, analyses those images, and looks for pests and diseases. If it discovers that in those areas there is a pest or a disease, the data that has been collected on that farm is then analysed, along with things like weather data, to determine whether or not, how widespread that is and what kind of treatment needs to take place. Having determined what needs to take place, the treatment is then suggested to the farmer. So the farmer is then given a series of options. Does he want to go with treatment plan 1, 2, or 3? The farmer then selects which of those treatment plans he wishes to go to, based on cost and other factors that he has to take into account. That is the only input that the farmer has in the whole system. The system then automatically goes online, buys the lowest cost pesticide that it can find that fits the bill. It arranges for that to be, it works out exactly how much pesticide it's going to require. It arranges for that to be delivered to a contractor. The contractor then puts it into his sprayer. At the same time, a map is downloaded telling the machine where it has to actually apply that pesticide. The contractor drives to the right field, which is he's given by his GPS coordinates. He goes to the right field, he drives up and down, and the machine, as he drives it up and down, automatically sprays the right amount of pesticide on the right areas within that field. At the same time, it updates for compliance records, for the records of exactly what it's applied and where it's applied this. This data can then be shared, if the farmer wishes to, with other people, including supermarkets, who can then tell their customers what chemicals have been applied to that particular crop. A second example of connected farming is by mounting sensors on animals, you can tell an awful lot about the animal's behavior and welfare. But also, one of the things that we're very interested in the UK is trying to put sensors onto every single animal in the UK. So that's every single cow, every single sheep. So we can measure where it is, so we can monitor where it is and how it moves around the country. We're interested in looking at that so that if there is a disease outbreak or if there is a problem, we can automatically trace which other animals that animal has come into contact with. But also, we want that information so that we can, when the animal goes to the slaughterhouse and is killed, we can see exactly where it's been, what treatments it's had, how it's been looked after, and from that we can deduce what we need to do to get better conformity of livestock within the sector. One of the biggest problems that we have is that because of the way we produce livestock in the UK, is that we do not get a uniform product. In America, they have large feedlots, and they get a uniform product. In the UK, we do not have large feedlots and do not get a uniform product. Therefore, what we're trying to do is develop ways of actually minimizing that change in uniformity. That information goes from that's collected right at the end of the food chain when it goes to the supermarkets. The supermarkets have a big problem. They want to sell you, as a customer, a steak. They want to sell you a steak, and the steak has to be a certain size to fit in their packaging. They also want it to be a certain thickness so that every time you buy a steak, you can go and treat that steak, you can put it on the grill, and it will cook exactly the same way for exactly the same time. If your product is not uniform, what happens is you have some thin steaks, some thick steaks, all of the same weight, and when you cook it, it cooks differently every time. So the supermarkets are driving the move towards more uniform meat products. They've already achieved that in pigs and in poultry, and now they're looking to do that in beef and in lamb and other animals. Okay. This is another project that we're working on, where we're working with a horticultural grower to produce flowers in pots. And what we're looking to do is, at the moment, there is a very labour-intensive process. And what the grower wants to produce is a plant that he had put in the minimum amount of water, the minimum amount of fertilizer, the minimum amount of pesticides, so he's controlled exactly what's put onto that individual plant to keep his costs to a minimum. He also wants to use robots to move those plants around to get rid of the labour problem. So what we're doing is, we've got a long-term project with this company. What we're doing is looking at how, firstly, we manage the data from that company, so that we're looking at how we can take all of that data that's collected as they grow the plant. But we're also looking at totally automating the whole system. So we want to automate the entire system, replacing all of the labour with robots. This is a complete connected farm, okay? Because what we're doing is we're keeping records of everything from the second the plant is ordered to the second it is delivered to the customer. We have a complete history for that plant. We are looking to use hyperspectral cameras to look at each of these plants individually and treat each of these plants individually, so that we can identify any pests or disease problems, and we only put pesticide or fertilizer onto the plants that actually require it, to try and absolutely optimize the growing of this crop. The data is then connected to the customer. The customer can look at any time. So if you're a potential customer, you can look online at the plant. Data will then be sent to you to tell you what that plant will look like in 2, 3, 4, 5 weeks' time. So if you are a shop that sells plants, you can say, right, what am I going to order when? You can look at it, see what it looks like before you've ordered it, know which day it's going to be delivered, and then that will be delivered to you in the perfect condition. The other advantage that you've got is that you can plan ahead, so you know what you've got in terms of crop coming in or plants coming in, so you know that they're going to be perfect for your customers when you buy them. Okay, so what are the take-home points from this? Okay. The first is that the world is effectively going to need 70% more food in 30 years' time. Therefore, there's going to be a huge challenge in actually producing that. digitally connected farming is going to provide have to do a lot to increase food production. It's going to have to do a lot to increase it. The second point is that the current agricultural revolution, the digital revolution, and any other digital revolutions that we're going through are going to take place in a very, very short place of time. The iPhone is now 10 years old. Okay, 10 years ago, there was never an iPhone. That's how fast. Now everybody has got a smartphone. Most of you are sitting here with a smartphone either in your pocket or in front of you. That is the rate of change, and that rate of change is increasing. It's increasing at a logarithmic rate. You're going to see AI and other systems develop very, very quickly. They're providing new tools which allow us to develop all of these technologies very fast. Connected farming is going to totally revolutionize the way farmers work. It's going to revolutionize the way that they interact with the people who supply them things, the people who they sell things to, the people who provide them with services, how those services are delivered, how they sell things. It's going to totally revolutionize the entire farming business in the space of less than 20 years. Major manufacturers are very aware of this. If you go and talk to John Deere, if you go and talk to a number of other major manufacturers, you will find that they are very aware of this, and they are putting an enormous amount of effort into trying to stay at the head of the game. If they don't, they will be out of business. Most of the agronomy companies in the UK are very concerned about how rapidly this is changing and how it's going to impact on their businesses and how they're going to give advice and guidance to farmers. You can use, we're talking with people who are looking at using digital agronomy. So they're going to provide all their agronomy advice digitally through either your smartphone or through a computer. It is fundamentally changing the entire way in which the farming industry will work. And that is also going to be reflected in all the other businesses that are going to be affected by digital technologies. It's going to fundamentally change the way the whole world actually works. Finally, this creates massive opportunity. Because the rate of change is so fast, those who are at the front of the game, those who are ahead of the game and who understand how this is going to impact, have massive opportunity to be new businesses. We are predicting that in the UK that some of the long-established agricultural businesses will be gone. They will be gone within 5 years. And there will be new players who will come through, who will be nothing. They're nothing at the moment, and they will be big players within 5 to 10 years in the agricultural industry. And that is likely to be replicated right across the world. There are going to be a lot of new companies coming through, and there's going to be a lot of older companies who deliver older services that are going to be out of business. Okay, so those are the 4 take-homes that I want you to basically get your head around. Those are the things that are important. Those are the things that are driving this technology, and those are some of the impacts that they're going to have. Okay, thank you.